Greetings, students. Joanne Myers here. I look forward to helping you understand Chapter 8. Chapter 8 is all about expressions, but I first want to start with differentiating between an expression and an equation. Simplifying an expression means to make it simpler. Solving an equation is what you have probably done over 100 times if you've taken an algebra course. So there's a division right here. To simplify is to make it simpler or easier. To solve means tell me the value for x that makes it true. Now, beginning in grade school, teachers will say, solve this problem, 4 plus 5. 4 plus 5 is 9. 4 plus 5 is not an equation. 4 plus 5 is an expression. An expression is half of the story. It's giving you one piece of information, and then you are giving the other half of the story. So what you are really doing here is you are simplifying the expression 4 plus 5 and telling me that it has the same value as 9. So chapter 8 is asking you to simplify expressions. Solving an equation, the equation is when we give you both sides of the story. And then the solution to the equation is the value for the variable that makes the equation true. If you were to speak of math in terms of English, the expression is like a phrase. The equation is your complete sentence that has the verb to be. Your is the equal sign. So on the left side here, simplifying the expression, if we give you something like 3 times the quantity x minus 5 minus 2 times the quantity x minus 4, you can rearrange how it is and try and rewrite it in a simpler way. We have a distributive property that says if we're multiplying the number 3 by this binomial in the parentheses, we can distribute the 3 to each term. 3 times x becomes 3x. 3 times a negative 5 becomes minus 15. Similarly, we have a negative 2 that's being distributed or multiplied by each term in the binomial x minus 4. So negative 2 times x becomes your minus 2x. Negative 2 times negative 4 becomes positive 8. So now what you're looking at is 3x minus 15 minus 2x plus 8. When you're adding and subtracting, you can add and subtract in any order. So you would add the terms that are alike. Positive 3x minus 2x would give you a positive 1x. And then a minus 15 plus 8 would give you minus 7. So we have not solved this expression. We have simplified this expression. Well, in a math class, we'll say you've solved the problem. We haven't really solved it. We've simplified the problem. So again, it's a terminology issue. What you're going to be doing, all of the problems that you solve in chapter 8 are actually simplifying expressions. All right, before we go into chapter 8 and simplifying expressions, I want to show you quickly here how to solve an equation, because odds are it's somewhere you have learned this in your past, and I like to attach the new learning to prior knowledge or clarify prior knowledge. So here we are now over here on the right. The directions are to solve. If we are solving an equation, then we have to be given both sides of the story. So in this case, this highlighted green is the equation that we're solving. And the reason we know it's an equation is we've got an equal sign and we're told the information on both sides. Now, one place that this will often cause students confusion is here on the left. You'll notice it's very similar. This expression on the left, we are not told what it actually equals. We do not know the value of 3 times the quantity of x minus 5 minus 2 times the quantity of x minus 4. We are just given this expression and therefore asked to change change how it looks. How this applies to our nursing situation is we are going to be given an order from our doctor or nurse practitioner or prescribing individual. And whatever that prescription is, we are not legally allowed to change the value of that prescription. But the doctor is going to talk in milligrams, and most of our, which is weight, and most of our medication is in milliliters or in tablets. And so we will need to convert from the units of milligrams to milliliters or to tablets without changing the value. So most of the homework problems you will see in our Math 1120 class, clinical calculations, is we're given an expression and need to change how it looks or change the dimensions or change the units. Okay, back to solving our equation. What we did in an algebra class was we were given an equation like this here on the right, where we were told that the expression, 3 times the quantity x minus 5 minus 2 times the quantity x minus 4, has the same value as 30. And then we are asked to solve. Our solve means find the value for x that will make this equation true. The left side equals the right side, they balance. So we do all of our steps here to simplify the expression on the left. Remember, our expression on the left simplifies or has the same value as x minus 7. So we simplify the expression on the left and find out that x minus 7 has the same value as 30. So what we've done to solve the equation here, this first part of the process is simplification. We're just simplifying the expression. Now, this part right here is where we're actually solving the equation. When we are able to solve, well, the tool we use most often when solving is basically do whatever you want to both sides of the equation. I can't do whatever I want to the expression. That would change the value of the expression. But if I have an equation here, like x minus 7 equals 30, I can do what I want to both sides. My goal is to isolate the x. So how I choose what I'm going to do is I choose whatever's going to make life easier. So I'm going to rewrite this over here. I have x minus 7 is the same thing as 30. I want x by itself. What's blocking my goal is a minus 7. So I choose to add 7 to both sides of the equation. Keep the equal sign in the middle, keep it lined up. 30 plus 7 becomes 37. X minus 7 plus 7 becomes x plus 0. Well, x plus 0 is just x. So x is 37. This is the solution. X equal 37 is the solution because when I replace my x in the original equation by the number 37, the original equation will be true. And so here I am. If I check my work, I have put 37 in place of the x, and then I simplify the expression on the left. This expression on the left continues to simplify, and it simplifies all the way down to 30. And that is a true statement. So I have proven that when x is 30, the original equation will be true. So x equal 37 is my solution. All right, enough of our algebra review. Algebraic expressions. So in chapter 8, we are dealing only with expressions. We are not evaluating, well, we are evaluating some expressions, but most of them we are simplifying. identifying like terms, combining like terms, and using the distributive property. Those are the 3 goals of this chapter. Distribution, I think I learned at Halloween because I picture a little 3-year-old, 2 3-year-olds, one of them in a pink ballerina costume and another in a Spider-Man costume. And if I give one of them a mini pack of M&Ms and I give the other child corn nuts, generally they're not happy. Or if I give, instead of M&Ms, I give 15 packs of M&Ms and 1 small bag of corn nuts. I do not like corn nuts. So for me as a child, that would be traumatic because I would be really sad. They did not distribute the candy evenly. When we distribute in math, we distribute evenly. Math has got a lot of logical rules. They do not change. What you do to one side, you have to do to the other side of the equation. In this case, we don't have an equation to work with. So when we have a situation like -7 times the quantity x minus 2, our order of operations says we have to do what's in the parentheses first, but we do not have a numerical value for x. It's a mystery. But those who have gone before us have proven that this expression here on the left in green is the same value as the expression -7x plus 14. Apologize if you have red-green colorblind issues, they may look the same, but on the left is the same expression as the one on the right. They don't look the same, but they have the same value. I have taken this -7 and multiplied it by x to get -7x. I have taken the -7 and multiplied it by this -2, negative times negative is positive, and I've got positive 14. So what's happening here, given this expression, the first part that was dealt with is this expression here. I'll highlight it in yellow. That part has been rewritten to be -7x plus 14 because there's a math law. A property is a math law. The distributive property says if you're stuck multiplying stuff inside the parentheses, distribute what's on the outside, distribute that -7 to each term on the inside. X is one term, and then -2 is the other term. So multiply that -7 by each term on the inside, and you will have an equivalent expression. Now, here in blue, I have an expression with 4 terms. Terms are things that are separated by an addition or subtraction sign. So my terms here are 6, 14, -7x, and -8x. When I have terms, I can add or subtract them in any order that I want. I do need to remember that the plus or minus sign goes with the term behind it. So that's a -8x, a plus 14, a -7x, a positive 6. So that's why we're allowed to rearrange our expression as they do in the line below. Again, this -8x is the same as -8x. All right, now the terms that are alike, these are constants, 6 plus 14, you just add like dollars, you get 20. This term, -7x minus 18x, common sense, if I take seven xylophones away from you, and I take 8 xylophones away from you, I have taken 15 xylophones away from you. So the -7x minus 8x is the same thing as -15x. So those combine to be the same. The 6 plus 14 is 20. And there you go. Generally, we write the terms with variables before the constant. So this is how it will look in an answer key. It does have the same value as 20 minus 15x, and some people might prefer to write it that way because the negative then doesn't float off your page. But again, the negative sign goes with the term behind the sign. So my -15x plus 20 would be the final answer. Identifying terms that are alike The things separated by plus or minus have to have the exact same variable expression, or they have to have no variable expression and be constants. A constant just means a fixed number. Combining, bringing together the terms that are alike is what we did here in this step. That was step number 2. And then using the distributive property is what we did right at the beginning. It's not that you have to do these objectives in 1, 2, 3. These are just 3 objectives. All right, here's some practice. Simplify this, recognize the terms. These are the 4 terms. The terms that are alike are minus 5y and plus 2y plus 7 and minus 8. So here are my terms that are alike that have the variable y. Here are my terms that are constant. So my final answer, I lose 5 yellow somethings and I gain 2 more y or yellow something. So minus 5 plus 2, that's negative 3 of the same thing. 7 minus 8, you get $7 put into your bank account. They take out $8. The net equivalent is you've lost $1. So that would be your final answer. Negative 3y minus 1. Number 2. This would be 2y, and I'm going to focus on this negative 6. This negative sign goes with the 6 behind it. So think of it as negative 6 times a quantity, y minus 2. Negative 6 times y. Negative times positive is negative. 6 times y is just 6y. Negative 6 times a negative 2. Negative times negative is positive. 6 times 2 is 12. So that part in yellow is the same thing as this part in yellow, and then add the plus 3. My suggestion when you take these expressions, write it on your paper, put an equal sign, and then work straight down. Each line should have the same value as the line below it. So now I've got 2y minus 6y plus 12 plus 3. Well, the terms that are the like, the 2 with the y, 2y minus 6y. If I have 2 of them and I lose 6 of them, I'm down 4 of the same thing. We are not changing the exponents because when we add or subtract, we're just like putting things in or out of a basket. They don't change shape or form. 12 plus 3 is 15. That is my final answer. I am simplifying an expression. I am rearranging the rigmarole they gave me and rewriting it in an equivalent way that looks simpler, meaning it has less ink and looks more friendly. I am not solving the equation. When you solve the equation, you end up with like y equals some number. That is not what's going on in this work. We are not solving, we are simplifying. Please keep the questions coming. I'm very glad to help. I look forward to helping you succeed in this chapter. Glad to do more examples if you need it. Definitely post in the discussion and show your steps as you rewrite it. You don't have to write a lot of verbiage as to what you're doing. You could, in the discussion, write the word distribution here. You can also Google distributive property by the organic chemistry tutor, and you will find numerous videos about distribution. Sorry, I can't talk and spell. There you go. All right. Have a good day. Let me know if you have or need more help.